Welcome to my programming club. Today we will be solving Leetcode weekly contest 358. We will be solving all the problems of the contest. Now let's move to the first problem of the contest. And the problem statement goes like this. You are given a zero index integer array nums. You have to find the maximum sum of a pair of numbers from nums such that maximum digit in both of the numbers are equal. So, for example, let's take these two. Let's take this input. Now you will be able to understand what the problem statement is asking us to do. You will consider only those numbers. Let's say I consider two a pair of 71 over 24. What is the maximum digit in 71? It is 7. What is the maximum digit in 24? It is 4. These two are not equal, so we will not form such a pair. We will not form a pair of 71, 24. This pair is not allowed. Let's take another example. Let's take a let's take 71 and 17. Maximum digit in 71 is 7. Maximum digit in 17 is also 7. So these maximum digits are equal in both of the numbers. So this is a valid pair. So for all the valid pairs, you have to return what will be the maximum sum of the numbers in the pair from all the valid pairs. Return pair with maximum sum. Max sum. Uh, what will the sum comprise of? It will comprise of these two numbers, which are the numbers in the pair. So the sum will be 71 plus 17. It will be 88. So also this will be the maximum sum possible for among all the valid pairs. Now let's look at the constraints. So the length of nums array is of order 100 and the numbers are of order 10 to the power 4. So even if we make a solution of O of n square times complexity, and here is nothing but the length of nums array. 10 raised to power 2 raised to power 2, which will be 4, because nums length was given to be at max was given to be 100. It is lesser than 10 raised to power 8 operations. Allowed in 1 second. So, what will be the, if you do not know what these are, basically what happens is, let me quickly change the color. If the number of operations, these are the number of operations in the program, number of operations. Exceeds or becomes equal to these number of operations, 10 raised to power 8 operations, which are allowed in 1 second, then your program might generate a TLE. But here it is lesser than 10 raised to power 8 operation, the operation number of operations that our program will be performing. So it is lesser than 10 raised to power 8 operations. So you will get a accepted solution. Also, there will be extra time taken to check whether what is the maximum digit in a number. So to check what is the maximum digit in a number, we will take additional time it will show the overall number of operations will be. What we will do is, for example, 71, we will keep dividing 71 by 10. First of all, let's say if we divide 71 by 10, then the quotient will be 7 and the remainder will be 1. So the remainder will be the digits in the number and the quotient will be the next number to check. This logic will be more clear to in the coding part. I will be explaining this. As of now, I can tell you is addition of log base 10 and num will be done along with the operations. For each nested loop, for each number, you will be checking this many number of times, which is nothing but the number of digits in a number. So at max, num's length is given to be 4. Now because it's 10 raised to power 4, so there are 4 digits, or let's say 5 digits. So at max, this whole term will be 5. So it will be 4 actually, because we are taking log with base 10 and 4 into 10 raised to power 4, which is nothing but similar to 10 raised to power 4 if we take a approx value. So this many number of operations will not generate a daily and your solution will be accepted. Now let's look at the coding part of the problem. There you will be able to get a much clearer idea about what is the approach being used here. So let me quickly zoom out. I think it will be fine. Now what we will do is we will be running 2 nested loops. We will try to form the pair of current number with every other number in the nums array. And what is the condition to form a pair? The condition to form a pair is to check if the maximum digit in both numbers in pair are equal is equal. So if the maximum digit in both of the numbers which for which we are considering to make a pair is equal, then we can say that we can form a pair. Then we can form a pair. And we will be taking another variable maximum, and we will be updating the value of maximum according to the values addition value we will get after the addition of number 1 and number 2, which will constitute a pair. So we will be updating our maximum sum. And at last we will be returning it based upon whether the maximum sums value was I have taken initial value as a minimum of integer value, and if it happens to be minimum of integer value, then we know that uh, none of the pairs are feasible according to this condition, that the maximum digits in each of the numbers in a pair have to be equal. So then we will return -1, else we will return maximum sum. So this wraps up the first problem of the contest. Also, I forgot to mention that how we will be checking what is the maximum digit. This is to represent maximum digit. What we will do is we will take modulus with 10 of the number, and what the modulus give us, it will give us the digit from the back side of the number. For example, we take another slide. For example, let's say you were given 273 and you take modulus with 10, then what will be the remainder? It will be 3. So this is the last digit. Now, if we have gotten this last digit, we will now check for this part only. So our next number will be 27, which will be nothing but 273 divided by 10. It will be 27. So this is how we will be generating parts of the number and checking the last digit. And among all the digits, we will find the maximum digit. So among all the digits, we will be keep updating our maximum digit. We will keep updating our maximum digit, max digit. At last, we will be returning the max digit, and it will be used for the comparison of max digit of the two numbers that are considered for making a pair. So that's pretty much it. Now let's move to the second problem of the contest. This is the second problem of the contest, and the problem's name is double a number represented as a linked list. So there is a linked list, singly linked list representing a number. So what you have to do is you have to double the number that is being represented by the linked list and return the new linked list, return the head of the new linked list that will be formed after doubling the number that it is representing. For example, let's say you are given this input, or let's copy this linked list itself. Yeah. So this is the linked list given to you. Double it. What is the number being represented here? You should read the number in this fashion. It's 189. You have to multiply it by 2, and accordingly, which will be 378. You have to read form a new linked list and return the head of the newly formed linked list. This will be the head. Let me quickly change the color. So this will be the new head form. You have to return it after doubling the linked list. So how you will be doing it? Now let's also have a look at the constraints of the problem. Constraints are the number of nodes in the list is of the order 10 raised to power 4, and all the values of the nodes lie between 0 to 9. And the input is generated such that the list represents a number that does not have leading zeros except the number 0 itself. So input is given such that your whichever the number is represented by the linked list, when you double it, it will not have leading zeros. It will not be something like this. So except if you are given, let's say 0, if you double it, it will be 0 itself. So that's what the problem statement and the constraints are saying. So now if we forgot for a second that the linked list is there, we simply know that the number represented is this. So how we divide by 2 in mathematics? We start from the very end. We multiply it by first by 2. So 9 to the 18, 1 carry. This is the carry. Now let me quickly change the color. Carry is 1 here. Here it was 0. So initially carry was 0. Now here it will be 1. How we are calculating the carry? 9 to the 18. We are what we are doing is we are taking mod with 10. So this will be the digit that will be added to the answer. And what will be the carry? 18 divided by 10. It is nothing but 1. The quotient will be 1. So it will be carried forward. So 8 to the 16, 117. It will be 1 will be carried forward because it's 17. So modulus with 10 will give us 7. And division with 10 will give us 1. It will be the carry. So 2 into 1, 2 plus 1, 3. This is the number. And also, if there have been a case, let's say there was one extra carry, let's say there was 5 instead of 1. So 5 to the 10 plus 1, 10. 1 would have been here. It will be, let's say it was 11. Then 11 mod 10 is equal to 1. And 11 divided by 10 equal to 1. So carry will be forward. But the number that was given to us has already ended. And 1 carry is remaining. So we will be forming a new node to represent this carry. And yeah, that's pretty much it. So a new node will be formed, and all of these digits will be formed in a new node. And at last, this will be pointing to null since it is not having any next. So what we will do is, since we are starting from the end, we are required to have the address of this last node, this node. Let's say we form a value previous, and previous is currently pointing to null. So previous is here. Let's say this is null, and previous is currently pointing to null. So what we will do is we will store all the values in the stack. We will be starting from 1, and we will be iterating in this fashion, left to right, and we will be putting all the values in the stack as we encounter them. First we will encounter 1, then 8, and then 9. Values will not be stored. Their addresses of the node will be stored. Addresses of node. So the address of node with value 9 will be stored. Address of node with value 8 will be stored, and address of uh, node with value 1 will be stored. This will be a stack of list node. List node is the data type of the given linked list. So you will be having at top, you will be having 9. So what you will do is you will take out 9. Let me quickly clear the board out. Yeah, it's fine, I think. We will take out 9. Node with a value 9. Previous is currently pointing to null. Previous is null currently. So your current node will be 9. We will multiply it by 2, which will give us, we will multiply its value by 2, which will give us 18, of which 8 will be added to our answer, and 1 will be taken as a carry forward. So you will form a new node with value 8, and carry which we will take forward is 1. And along with that, what you will do is you will make your current node to point to current nodes next to point to previous. So current node next will be pointing to previous. This was previous, and your previous will now point to current. So previous is pointing here, and yeah, that's what we will do. And then we will take another node out. Let's say we this time we take 8 out. Uh, Now current will be pointing to node with value 8. So we will multiply it by 2 and add the carry. What we will do? 8 into 2 plus carry. 8 into 2, 16. Carry was 1. So it will be 17. We will take only 7 and comma new node. And 1 will be carried forward. So carry will still remain 1. So I hope you are able to understand. So this will be your current node. Current nodes next will point to previous, and previous will be updated. Now previous will point to 7 and carry will be 1. So on you will continue and you will be able to generate your result. In case your number that was represent the length of the number is exhausted. Let's say it was of length 3. Length is exhausted, but the carry is still remaining. It is still greater than 0. Then you will add one node extra, and you will return the address of this node. Otherwise, you will return the address of the last current node that you will be pointing to. The logic will be more clear in the coding part. Now let's quickly dive into the code. Let me quickly zoom out. I think it's fine. Yeah. So what we have done is currently our previous will be pointing to null initially. Our previous will be pointing to null. We will be storing all the values, storing all the values of given linked list in a left to right fashion in the stack of list node. So once you have formed the stack, what you will do is you will just mimic the multiply operation with the help of stack, and accordingly you will be updating your previous and current nodes value. If after you have exhausted the length of the given linked list, after you have exhausted the length of the given linked list, if there is still a carry left, then you will form a new node. Then you will form a new node and make its next to point to the previous node. And you will return that new node, otherwise you will return the end. I hope you are able to understand the problem. If problem solution. If you are still having any doubts, please feel free to ask them in the comment section. Now we will be moving to the third problem of the contest. So this is the fourth problem of the contest, third problem of the contest. Pardon. Uh, the problem's name is minimum absolute difference between elements with constant. So you are given a zero indexed array. Let me quickly zoom in. Yeah. So you are given a zero indexed array, nums, and an integer x. So what you have to do is you have to find the minimum absolute difference between two elements in the array that are at least k indices apart. So what the program statement means by this is, for example, let's take this input. Let's mark the indices of the array 0, 1, 2, and 3. So we have to take those indices which are at least x distance apart. So you can only be starting from this index 2 because it is the first index which is having I index which is k distance apart, x distance apart from it, which will be nothing but 0. For 3 it will be 3's index is 1, 1 minus 2 will be minus 1, which will be out of the bound of the indices of the array. And for 0 it will be minus 2, which is also out of the bounds of the indices of the array. So first index that will be having I index at least k, at least x distance apart is this 2, this index. So we will be starting from the value of this distance itself, the value of the index which is the having the value of distance itself. This is, I hope you are able to understand. So 4 it is the only index for this index 2, which is at least x distance apart from it. So what will be the absolute difference of 4 and 2? It will be 2. So this is one thing. Now you will move to another index. Let's say you move to this third index. So what will be the indices that are at least k distance apart from this? There will be two such indices. One will be 0 and one will be 1. For 3, there will be two such indices. Third index, or there will be two indices. One is 1 and another will be 0. So let's take absolute difference of this with both of them. For the 0th index, it will be 0, since 4 minus 4 will be 0. And for the first index, it will be 1. So among all these differences found, what is the minimum? 0 is the minimum. So among all the possible set of pairs of indices, among all the possible set of possible pairs of indices such that indices in a particular pair are at least x distance apart. Among all such possible pairs, what you will return is you will return the pair with minimum absolute difference. Return the minimum absolute difference possible. So this is what you have to return. So here the minimum absolute difference was 0. So you will return 0. You can check with the output also, it's 0, because it have taken the number of the index 3 comma 0, which have what we have also taken 3 comma 0, and yeah, this 3 comma 0, and it will give us 0 as the difference, and we will return that. So let's look at the constraints of the problem. So the length of the array is of order 10 raised to power 5. The elements in the array are of order 10 raised to power 9, and the distance which is given to you, the least distance that will be given to you, which is x, lies between the length of the nums array and 0. So what will be a brute force way to solve this problem? Brute force way is to brute force. Let me quickly change the color. Brute force will be to generate all possible pairs and check if they are valid. If they are valid, for valid, it is to be noted that the indices in the pair should be at least k distance apart. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach of the problem. So, if they are valid, then check their difference, check the absolute difference, and return minimum absolute difference possible. Return minimum absolute difference possible. So what you can do is you can just run two loops, nested loops, and form all the possible pairs. Let me quickly change the color. You will be taking two nested loop, form all possible pairs. Then you will check which one are valid ones. And among the valid ones, you will be taking absolute differences. And you will be returning minimum of such absolute differences. So it will take you O of n square time complexity. And since n's value here is 10 raised to power 5, 10 raised to power 5 square will be 10 raised to power 10. This 10 raised to power 10, let me quickly take another slide. This will be the number of operations that will be at least required to solve via brute force way. This is greater than 10 raised to power 8 number of operations allowed in 1 second. So those of you who are not familiar with this concept, if the number of operations of your solution reaches equal to or greater than 10 raised to power 8 number of operations, then your solution may generate a TLE, time limit exceeded, and it will not be accepted. So I will also be providing a link for article describing how the time complexity of accepted solution varies according to input size. Basically, what right now what can I tell you is that you are allowed to perform lesser than 10 is to the power 8 number of operations, and if your the operations that your solution is performing are lesser than 10 is to the power 8, then you are on a safer side and your solution will be accepted. If the number of operations reaches equal to this 10 is to the power 8 limit or becomes greater than this, then you may get a TLE and your solution will not be accepted. So in order to get your solution accepted, you have to optimize on this brute force. Optimize. How you will be optimizing is will be a further portion which you will be asking. So let's have a look how you will be optimizing. Optimizing brute force. Let me quickly change the URL again. So let's say I give you a sorted list 1, 2, 3, 4, 5, 6, 7. Now you are currently checking to form a pair with number 4. You want such a pair that forgot about the list distance here for some time. Now let's say you are considering to form a pair with this number. Considering to form a pair with 4 and any one number in list given. Now list will be in sorted form. So this is the list given to you. What you can do is you can let's say this is the list. Let's mark the indices 1, 2, 3, 4, 5, 6, 7. So if I run a binary search for on this list, this will be your target. You will be searching for target in this list and you will be running binary search for target on list. And what your binary search will returning to you? It will return you, let's say your binary search returns you lower bound of target. What is the lower bound? You may ask. Let me quickly take another slide. So we are talking about lower bound of let's say 4. It will be the least number in the list which is not lesser than 4. Let's say 1, 2, 3, 5 is given and you are checking lower bound for 4 in this list. This is a given list to you and you are checking lower bound of 4 in this list. What will be the least number that is not lesser than 4? This 5 will be the least number uh, which is not lesser than 4. Least number in the list which is not lesser than 4. This will be 5. Your lower bound function will be returning a iterator pointing to iterator is just a pointer in C++. Or let's say in Java language or something, you will be having an index of 5. It's kind of an index, but it's the actual address of 5. So at which 5 will be stored. Let's call it IT. You will be return a pointer pointing to 5, which is the lower bound of 4. So what will be the least difference possible with 4 among all the values in this list? Uh, Let me quickly take another slide. What will be the least absolute difference possible among all the values in the list? You will greedily pick the lower bound. Let's say 5 was not here, instead it was 6. So lower bound would have been 6, since it is the list number which is greater than or equal to 4, which is not lesser than 4. So you will basically be having two options, either to take the lower bound, which is 6, or you can take a number just previous to this lower bound. Whichever will give you the minimum absolute difference, you will take that. Since the list is in sorted order, these two options will be sufficient to check the minimum absolute difference that you can get, which is 4 minus 3 absolute difference will be 1, and 4 minus 6 absolute difference will be 2. So minimum is this one. So why we are checking only for these two? Because the list is in sorted format. It will guarantee you that these two are sufficient if you want minimum absolute difference with 4 of any number. You will be forming a pair with 4. These one of these two will be having minimum absolute difference. So among whichever gives you minimum absolute difference, you will form a pair of that number with 4. So I hope you are able to understand till here. So what we will be doing is uh, and what is the runtime complexity of this lower bound? This lower bound is nothing but a binary search. So it will be log of n. N is the length of the list. Let's call this list. So the length of the list will be n. It will be log base to n, which is formally log of n. So yeah, this will be the runtime complexity. And what you will do is, let's say 1, 2, 3, 4, 5, 6, 8, 9. Something like this is given to you, and x value is given to be 2. And let's mark the indices 0, 1, 2, 3, 4, 5, 6, 7. So you will be starting from the value which x is having, the list distance, and you will be checking all the values. If let's say all the values previous to this current index, all the indices, all the values of the indices previous to this current index are present in a sorted list, Let's say these are the previous indices values and they are present in a sorted list. Then you can apply the same technique that we have discussed for this lower bound and given list on that list, and you can find out the minimum absolute difference in log of n time. And here will be the, let's call this list, and here will be the length of the list. And you will be doing this for every index from x to the end of the given array. Let's say, let's call this array as ARR and let the length of this array be, let me quickly change the color, M. Then you will repeat this operation of order M times, starting from the X index to M minus 1 nth index, which is of M times. So this will be your time complexity. And n here he will also be equal to, will also be of order M. Since what this list is forming, this list is forming from the indices of the given array. So it will be O of log of M into M and log of 10 raised to power 5 into 10 raised to power 5. These are the number of operations your program will be running. Let me quickly take another slide and write there log of M into M. Number of operations 10 raised to power 5 log into 10 raised to power 5, which is lesser than 10 raised to power 8 operation. So your solution will be accepted. And that's the approach. Now let's quickly dive into the coding part of the approach. And there you will be able to understand it in a more clearer way. Let me quickly zoom out so that a larger portion of code is visible to you. So what we have done is, initially we have taken the minimum difference as maximum value of our integer possible. This stores the current size of the given array. So this set is to this set is to maintain. Also, for the time complexity that I was mentioning, log of n is to search, but to maintain all the previous indices in the sorted order, it will be, yeah, it will be same. It does not matter. It will also be m log n. To maintain all the indices, this set will also be requiring the set that we are talking here. It will also require m log n space. M log m into log m. So time complexity will still remain same. So to maintain the indices which are x distance apart from the current index being considered, maintain the indices which are x distance apart from the current index being considered in a sorted format, so that we can apply binary search to find lower bound for the value of current index. So what we will do is we will be starting from the x, since this is the first index which will be having a integer which is at least x distance apart from it. So starting from x, we will iterate over the given array till the very end, and we will take another pointer. This pointer is to help us enqueue, uh, help us add the indices which are at least x distance apart from the current index being considered. So it will be helping you in that operation. Uh, if the this pointer is lesser than the size of the list, what you will do is you will insert the value. Uh, uh, this pointer is pointing in the set so that it will be in a sorted format. Then you will find the difference, minimum absolute difference, minimum absolute difference possible with the current index being considered. What will be the current index being considered? It will be INDX. So you will find the lower bound. It is nothing but variation of binary search, a variation of binary search. So once you have found the lower bound, you will check if the lower bound value or the value previous to it is giving you least absolute difference. With the element at current index. Which is the what is the current index? INDX. So you will be checking uh, which value is giving you the least difference. Move one value, one, let's say, index, or say address previous then the lower bound. Then with the minimum absolute difference, you will be updating your result, updating the value for say result to be returned, and at last you will be returning the minimum difference possible. So I hope you are able to understand the problem solution. And if you are still having any doubts, please feel free to ask them in the comment section. Now we will be moving to the final problem of the contest. For them, the final problem of the contest, and the problem's name is apply operations to maximize the score. So you are given an integer array in nums of n positive integers and an integer k. Initially, you start with a score of 1. Okay. Then you have to maximize your score by applying the following operations at most k times. Choose any non-empty subarray from index L to R that you haven't chosen previously. Choose any element X of this subarray with the highest prime score. The prime score of a number X is equal to the number of distinct prime factors. So it will be equal to the number of prime factors of a number. So choose an element X uh, with highest prime score. If multiple such elements exist, it is to be noted that you have to choose the element with the smallest index. Multiply the score by X. Return the maximum possible score after applying at most k operations. Since the answer may be very large, you have to return it with a modulo. So what the problem statement is saying, let's try to understand with the example. First of all, let's say this is the array given to you. 1, 2, 3, 4, 8, 9, 10, something like this. What you have to do is you have to consider all the subarrays in the array. Let's say you consider this subarray and let's mark the indices of the array 0, 1, 2, 3, 4, 5. So let's say you chose a subarray. A subarray, those of you who do not know what a subarray is, subarray is a contiguous part of array, provided that the order of the element in that contiguous part remains same as that of the original array. And the subarray should be non-empty. So you cannot take an empty array and call it a subarray. Non-empty contiguous part of array, provided the order of the elements in the subarray is same as that of the order of those elements in original array. This is the original array. So this is what a subarray is. Let's say you take subarray from index. This is the left limit and this is the right limit 1 to 4. So what you will do is, let's say you do prime factorization of 8. It is 2 comma 2 comma 2 2 raised to power 3. So it is having only one prime factor, one distinct prime factor. So the score of 8 will be prime score of 8 will be prime score 8 will be 1 since it is having only one distinct prime factor. Now let's say the number given was 3 and the prime score of this will be it will be 2 comma 3, which is 6. So the number of distinct prime factors are these two. So it will be 2. I hope you are able to understand by what is the meaning of prime score here. It is nothing but the number of distinct prime factors. Number of distinct prime factors. This is what the prime score for a number is. Now for this given subarray, you can choose any number in this range, and what you will do is you will choose that number and multiply it with your result. Initially, uh, you have to return the score. Initially, the score is having one value, and you have to multiply the number with largest time score in the subarray considered. And let's say here, what is the number with the largest prime score? Largest number with the largest prime score. Because we want to maximize score, so we want largest number. So first of all, the prime score should be maximum, and we greedily want maximum number. So 9's prime score will be 1, 8's prime score will be 1, 3's prime score will be 1, and 2's prime score will also be 1. So all these are having 1. And if all the numbers are having same prime score, if multiple such numbers exist, you have to pick the one with the smallest index. So here you cannot greedily pick 9. You have to pick one with the smallest index. You have to pick this 2 and multiply it with the current score. So current score will be 2. If let's say here it was 6, or let's say let's consider a higher number. Let's say it was 10. Then its prime score would have been 2. So we would have multiplied 10. Greedily picked the highest number with the highest prime score. So you would have got 10 here instead. So this is what you have to do. You can perform this picking of the number with the highest prime score at most k times. So after applying at most k operations, you have to return what will be the maximum value of the score. So you have to maximize your score by performing this operation. This is the operation you will be performing. What is the operation? Picking up, number one, picking up with a subarray of any range that has not been picked before. Not been picked before. It is the condition that it should not have been picked before. This range, particular range, should not have been picked before. And you will find the number with the largest prime score in this subarray range and multiply it with your score. And you will do this whole operation. Let's call this operation. You will do this whole operation at most k times, and you will maximize your score. And you will answer what is the maximum score. You will return the maximum score. So this is what the problem statement is asking you. Also, let's have a look at the constraints of the problem. So let me quickly take another slide. So the length of the nums array is given to be of order 10 raised to power 5. And the numbers in the nums array are of order 10 raised to power 5 also. And k is in the range 1 to minimum of n into n plus 1 by 2 for 10 raised to power 9. N into n plus 1 by 2 is nothing but the number of subarrays, number of subarrays number of subarrays of an array of size n. So case value will be minimum of these two. So what will be the brute force way to solve this problem? It will be to generate all the subarrays and perform operation only on those subarrays which will give us maximum score. So you cannot readily find only those subarrays which will be giving you maximum score. Before that, you have to find all the subarrays. So to generate all the subarrays, these number of operations will be required, and the range of the number of elements in the sub in the given array is of 10 raised to power 5 and into 10 raised to power 5 plus 1, which is roughly 10 raised to power 5 square, 10 raised to power 10. These are roughly equal to 10 raised to power 10 operations. And 10 raised to power 10 operations are greater than 10 raised to power 8 operations. Allowed in 1 second. Uh, those of you who are not familiar with this concept, but basically in 1 second you are allowed to do 10 raised to power 8 operations, and if the number of operations that your solution is performing becomes equal to 10 raised to power 8 operations or exceeds 10 raised to power 8 operation, then you may get a TLE and your solution will not be accepted. So what you have to do, you have to optimize this brute force approach. Now question arises how you will be optimizing it. Since we want to maximize our score, since we want to maximize our score, we want score to be multiplied by maximum numbers, largest numbers in the array. In the given array, given input array. We will pick our subarrays of range L comma R such that we will be multiplying this score with largest numbers possible. So we will greedily pick the largest number. Now you may ask how you will be picking the largest number greedily. So let's say this is the subarray given to you and you want to pick this number 3. Now let's say this is not a subarray, this is a array. Now how many subarrays are possible. Those have three in it. So these number of subarrays will be possible. The total is 9. So how you will be getting the number of subarray possibles, which are having 3? What you will do is you will take length of this part from, let's say this is your left and this is your right and this is your mid. What you will do is you will do mid minus left plus 1 into right minus mid plus 1, which is basically nothing but it is number of elements in this part multiplied by the number of elements in this part. So it will be 3 cross 3 is equal to 9. I hope it's clear to you how you will be finding the number of subarrays that will that will include a particular element. So let's move to the previous slide. Now let's say you sort the given array according to decreasing values of elements in array. Since we are greedily taking the largest elements possible, we sort the given array. Also, for this solution, proceeding further in this solution, you will be requiring 4 concepts: binary exponentiation, concept of monotonic stack, next greater element. This next greater element is a problem. Then you will learn the application of monotonic stack. Also, previous greater element. This is also a problem which includes application of monotonic stack. And the last thing that you will be needing is Sieve of Eratosthenes. Pardon me if some spelling is incorrect. This spelling is particularly difficult for me to spell. Uh, Sieve of Eratosthenes. These are the 4 concepts that you will be requiring to proceed further in the solution. I will be providing link of all this, link of articles describing all these concepts. Please go to those links and explore them if you are not familiar with this concept. And only then you should proceed further. Now I hope you have explored those links, and if you are familiar with this concept, then you can move ahead in the solution. Now let's move ahead. What you will do is doing the following operations. These are the operations that you will be performing. Or say steps that you will be performing. Number one, what we will do is you will find the prime scores of each element with the help of Sieve of Eratosthenes. It will basically be used for finding prime numbers, but you will modify this sieve and you will find the prime scores for each element. Next, what you will do is, since we are greedily picking, what we will be doing is to maximize the score, we will greedily pick maximum value numbers. In nums array, we multiplied with score. You will be sorting the nums array according to the value of the numbers in decreasing order. According to value of numbers. Also, you will preserve the order, or say indices of those numbers. Now, ask why we are preserving the indices. Because with the help of indices, we will be using first monotonic stack, this monotonic stack concept, to find the next greater element for each element in the nums array in terms of prime score values. What I mean by next greater element is, for example, let's consider this array 1, 2, 3, 1, 7, 9. So these are the prime scores, and these are the indices of the numbers, and these are the indices of numbers. And these are their prime scores. So let's say you are at this prime score. What is the next greater prime score? For this prime score, it is 7. Now let's say you are at this 7, or let's say you are at this 1. What is the previous equal or greater prime score? It is nothing but 3. For 1, it will be 3. I hope you are able to understand what is the previous equal or greater prime score and the next greater prime score. Next greater prime score. So with the help of monotonic stack, you will be finding this for each of the numbers. Next greater prime score and previous or equal greater prime score. So after you have done finding these three things, what you will do is, let's say you are, let's move to the example that we have taken previously. Yeah, this example. Let's say you are considering to include this prime score. This is a prime score that you are planning to include in your score. What I mean by including is, you will multiply your score with 3. So these are the number of subarrays possible. Those have 3 in it, and it can be achieved with the help of these two entities. Basically, these are the lengths of this part, and the length of this part. So once you are multiply the length of this part, you will get 3. So you will get 9, which is 3 into 3. 1 to 3, it is having length 3. 3 to 4, 3 to 5, 3, 4, 5, it is having length 3. So 3 into 3 will be 9. So there will be 9 such subarrays which are unique and which are having 3 in them. So I hope you are able to understand. So if I select these subarrays, then and in these subarrays, let's say 3 is having the maximum prime score, then we will multiply 3 with score these number of times. Which number of times? As many the subarrays, number of subarrays possible, those have 3 in it. So this many number of times you can multiply 3 with 4, your given score. I hope you are able to understand. So this is the this will be the contribution of 3. What we will do is we will find the maximum, we will find the contribution of larger elements in nums array. First, what is the contribution? Contribution to score, contribution to source value. Contribution is basically how many number of times a number will be multiplied with score. We will greedily pick larger numbers so that their contribution will be larger. So this next greater and previous greater will come handy in. Let's say this is the given range for which you will be considering. This is the current number that you are picking to be multiplied. Number considered to be multiplied with score. How many times you will be multiplying this number? It will be number of subarrays minimum of number of subarrays containing this number of unique subarrays or present value of k. Since you are performing these operations at most k times, whichever is the minimum, you will be multiplying this number with score that many number of times. So you will find, let's call it power, number of times as power. So you will multiply score into, let's call this num raised to power. The number of times you will be multiplying this number with score. So here for calculating this power, binary exponentiation will be used. The link to which I have provided you in the description of the video. Please check that out. I have also told you to explore these links before moving to the solution. These links that I will be providing. Before considering these steps, you should explore these links. So this will be it. And for you will be performing operations k number of times, and when you are done performing k number of times these operations, then you will return the present score. So let's quickly dive into the coding part. Basically, in the coding part, I have explained each and everything with the comments. It is same as that we have discussed in the slides. If still you are having any doubts, please feel free to ask them in the comment section. So thank you for watching. Thanks.